Yeah? Good. Okay, so we now understand cause and effect. We can't assume that because of the probability level we're working at. Okay, so we have to understand effect size and apply that appropriately when we're interpreting the results. Okay. So the next thing that we have to then do, and again we refer back to our research-led question. Okay, and you have to then think: are you looking at tests of differences, or are you looking at or interested in relationships between groups? Okay? You have to consider then, and this is where the importance of understanding your IV and your DV comes in. Okay? What is my IV and what is my DV? Okay? So if we go back to the creatine test on muscular strength, okay? Your IV is ultimately what? What you influence or what you manipulate. So in this case, the creatine test, it is the creatine. Yeah, we're delving down levels. It could be levels to our IV, okay, which is good. And my DV would be, if we're doing a 1 rep max bench press,
the results you get from it.
Yeah, what we get from our subjects. Okay, good. So as Steph then briefly touched on, okay, we have levels. We may have multiple IV and DVs. Okay, we don't necessarily just have one DV or one IV. We could have levels to it. So the amount of creatine that's being ingested. Okay, we might then look at muscular strength in terms of 1 rep max chest press, but we may also look at body fat percentage. So we would have multiple DVs there. Okay. You need to think then, what design do I have? Is it within subjects or is it between? Okay. Now you have to make that scientifically appraised approach as to how or which one of those is going to best answer your research-led question. What is the literature suggesting? Okay. What gap is there? How can you best answer your proposed question? Okay. From that, we then need to look at the type of data that's been collected, okay? And that is very, very important, okay? Students tend to get that bit wrong, okay? And if we get that bit wrong, we start going down the wrong road and we execute the wrong test, we can start then running type 1, type 2 errors, okay? We enhance that probability, okay? So, in terms of the data that we've collected in terms of our bench press and our body fat, what data do you think we've collected?
Can we see that again?
What data do you think that we've collected in that theoretical test that I've just put to you there? Okay. Now we're thinking about the data collection. How have we collected data in that creatine test?
Giving people creatine drink.
Collecting the data, not what we're manipulating. What have we collected? We've definitely collected quantitative data, okay? But in terms of the data, nominal, interval, ordinal, or ratio. Can you remember what they were? Can you remember last year when we went through data types? What's that? Okay. Is it that it could be ratio data? Can we remember different data types?
The ratio scales based on order. They have equal distance between scale points.
Is
and
that
use a 0 to represent absence of value.
There we go. So we are using 0 as an absence of value, aren't we? Because we can't have minus 1 kilogram, can we? No one can lift minus 1 kilogram. There's no such thing as minus 1 kilogram. Okay? When we haven't got, or when absence of values come into play, it could be temperature. Okay? Because 0 degrees does not represent the absence of heat. Neither does minus 20. Okay? That would be a different data type, which would then allow us, or we would have to run a different test. Nominal data, okay, would then give us something like male-female would be nominal data. Okay, we have to understand that because that will send us down one of two roads. It'll send us down parametric or it'll send us down non-parametric. Okay, and we'll discuss that a little bit further on. Okay. Finally, we need to then look at how many groups or means do I need to compare. Okay. A lot of stuff that has to go into that, but it's important because you can get all of those things that we've previously discussed in this module right, and you get this bit wrong, you execute the test, you get the wrong result, you start then discussing and interpreting things wrong. Okay? That could lead to the creation of a strategy that we put into sports science that isn't necessarily correct. It could lead you to making a practitioner decision with a client or with an athlete and getting it wrong. And remember, we're always chasing that 1% to improve performance, but we're running the risk of losing by 100%. Getting that wrong within your applied research could ultimately make you make that decision to lose the athlete by 100%. Okay, we're not going to do that because we're going to understand this and execute research the best way possible. There is our data types. Okay, when we look at ratio, which is what we would do within this creatine test, okay, you can see why it's important we understand. So when we look at nominal, like we said, we're counting categories, okay, the amount of football players in here, amount of females in here. Ordinal data would look at ranking, okay, so we would rank the data in order, okay, in with their height, but we don't have a beginning and end value, okay. Interval data would be equal units of measurement between data points with no absolute zero. I use the temperature because it is equal points, isn't it? -1, 0, 1, 2, 3. You can go to the minus of that, okay? But there is no absolute zero. Okay? Good and important we understand that when we are putting our proposals together, okay? And this is the reason why, okay? We have two different types of tests of differences, okay? Parametric, non-parametric, and this is where the collected data becomes important, okay? Parametric tests use at least interval or ratio data, and important, this is important. Remember, level 4, when we started going through normal distributions of data, okay? This paradigm, parametric, okay, makes an assumption that the data is drawn from a normally distributed population, okay? That may not always be the case, however, okay, and we'll run through how we go through testing if that is the case, but that is one of the things around parametric testing. There is an assumption that the data is normally distributed, okay? Non-parametric, we use nominal or ordinal data, so you can now see why it's important we understand what data we're collecting, okay? It makes no assumptions about the normality of data, okay? And these tests can be used, okay, if data is not normally distributed. Okay, so if it isn't normally distributed, we can then use non-parametric testing. Okay, and we'll not delve too much down this road, but they are deemed less powerful than parametric tests. Okay, and it's all about the power and frequency, okay, or the integrity of the data that we've collected, okay, and how much of that data represents the population that we are putting under investigation, okay. At this stage, at level 5, I don't think we really need to be delving down the the nitty-gritty of that as such. We'll do that next year when we actually start going through into dissertations, but this is proposing, and I want you to understand the basis of proposing before we then start critically appraising why we're doing X, Y and Z, okay? So, in terms of things that we've covered, okay, and we've went through the IVs. Do I have multiple IVs? What's my design? What data did I collect? How many groups or means do I need to compare? Okay, let's just have a little look at this. So let's assume we did a test to examine the difference between football players and basketball players' vertical jump ability. Both groups did 10 jumps and the mean score was recorded in centimetres. I think basketball players are going to be able to jump higher than footballers. Now, use that and answer those questions above. Okay, what do we get? So, what is my IV and what is my DV?
IVs are football players and basketball players.
Okay. DV?
DV is the jumps, who jumps higher.
Vertical jump ability. Okay. Do I have multiple IVs? Do I have multiple DVs?
No, it's just the jumps, isn't it?
So we have one DV?
Yeah, and one IV.
We'll have one IV.
Two football players and basketball players.
So we've got 2 IVs and 1 DV. Okay. What is the design in this particular research question?
Basketball players' ability to jump.
No, between.
Yes, so now we're looking at between or within. Okay. Is it between?
I would say between. I would say within, because they're all doing a vertical jump.
Within, because they're all doing all forms of the DV, aren't they? They're all doing the jumps, so both groups did 10 jumps. Yeah? Okay. What data did you collect?
Whether the basketball players jumped higher than football players.
Yeah, what type of data was it? Was it nominal? Was it interval? Ordinal? Ratio? What was that, Sophie? Ratio, yeah. Okay, because we're measuring height in centimetres, okay, but 0 actually denotes the absence of a value, okay, because we can't jump minus 10 centimetres. Oh. So, how many groups or means do you need to compare?
2.
Yeah? 2? Good. So, what test do we do then? Okay, so now we've established that. What test do we do? Okay? When you only have 2 groups or means to compare, you need to do a t-test. If you have 3 or more, then we can't do a t-test. Okay?
So what do you do if you have 3 or more?
What do you think we do? We'll come on to that.
Do multiple t-tests.
What would happen if we'd done multiple t-tests?
Get a comparison.
Think about, remember, we're working at 95% probability again. We're running the risk of increasing errors, aren't we, if we do multiple t-tests. We'll come on to that next. Okay, there is a test that we can do. Okay, so if it's between subjects, okay, we would then do what we call an independent t-test. Okay, if it's a within subjects, okay, it would be a paired samples t-test. So now we can see the importance of understanding which design we choose, okay, because ultimately going to dictate what type of test that we do, okay. So, just a few examples there, or an independent samples of between subjects t-test. I want to know if caffeine can enhance endurance. I have a team of 40 footballers. I take a baseline measure of the bleep test first, then administer the drinks and have them do the bleep test again. 20 footballers are given a caffeine drink before doing the bleep test. The other 20 footballers are given a placebo. I then look at differences in performance between the two groups. Okay.
Do them back to back.
Yeah, I mean, it's not exactly the most robust, so yeah, I appreciate the fact that you've picked that up. It's just an example of, between groups. There is things that would have to think, right, okay, it's a maximal test. We're going to have to put some form of intervention in place in order to then get a maximum, or to be able to test the variables, okay? It might be a different day, etc. Okay?
How the two groups split up?
How were they split up? How would you have split those groups up?
I'm not sure.
Random?
Have to be random.
Yeah.
Does it matter, like in that case? It's just...
Yeah, it would matter, I think, because we would have to eliminate any chance of researcher bias. So if we had some endurance athletes, we could strategically place those into different groups. Okay, we randomly assign those. Again, it would be around your population. If it was done with elite endurance athletes and they were all elite endurance athletes, it wouldn't really make so much of a difference. But if we have a mix in there, then it certainly could do. Okay. So paired samples or within subjects t-test. I want to know if caffeine can enhance endurance. I have a team of 40 footballers. All 40 footballers do the bleep test twice. One time with a placebo, another with a caffeine drink. I then compare. Okay. So it's all about, the design is all about the subjects being within or between, and that will ultimately dictate which t-test that we would do alongside the data collected. Okay. So back to Sam's point, what do we do if we have three or more means to compare? And this is where an analysis of variance comes in, or what we would call an ANOVA. Okay? Like I said before, it reduces the risk of committing a type 1 error by doing the multiple tests. Okay? And it'll tell you whether there's a significant difference between the groups, but it won't tell you where that significance lies. What we have to do then is we have to run what we call post hoc tests, okay? But I will show you when we get on SPSS, and it's simply just clicking on a button saying post hoc, and then we select the correct post hoc test depending on what test we our whole strategy, okay? But I'll show you how to do that, so don't worry about that, okay? So with the ANOVA, okay, it is the most common test, because what we tend to do is we tend to look at whether one thing may affect another, but we have a control group in place, okay, and we might have time constraints as to when maybe a supplement may be administered, okay, or the time of day when a particular intervention was put into place. Okay, that has to be considered. Because we know about the physiological effects of different time of day, nutrition, feeding, etc. Okay. Again, it isn't just a case of running an ANOVA. Okay. There's a between subjects ANOVA, which is usually called univariate, and a within subjects ANOVA, which is normally called repeated measures. Okay. And it comes down again to your design. Again, just some examples. I want to say whether 3 different drinks can enhance endurance performance. I have 60 netball players to take part. 20 players have a placebo, 20 drink Lucozade, 20 drink Gatorade. Okay, it is the same testing protocol as the independent t-test. It's just now we're using an ANOVA because we've got 3 means to compare. Okay, repeated measures or within subjects ANOVA. I want to see whether 3 different drinks can enhance endurance. 60 netballers again. They each consume every one of the drinks in a specific order. They will do the bleep test after every drink. The same test protocol as mentioned earlier with the paired t-test. Now I know there should be some alarm bells and questions ringing in your head when I mention that, but it's just giving you an example as to how we would administer that particular test. Okay, now I'm only going to go as far as this one, okay, but we have what we call a MANOVA, okay, which is a multivariate analysis of variance. And we use this when we have 2 or more DVs. So now we've looked at the means of different groups. We're now looking at if we have 2 or more DVs. So it could be muscular strength and it could be body fat, okay? Or it could be, when we look at this, the effects of 3 different training methods would be 3 IVs on sprint times and vertical jump height, which would be 2 DVs, okay? The same principles apply as an ANOVA, but becomes a little bit more complex, okay, when we actually then analyse that, and especially when we come to then interpret the results. When we're inputting the data, it becomes a little bit more tricky, but again, you know, I've got them step-by-step guides that are all there for you next year. So don't worry about that if it does come to that when you're executing data for your dissertation. Remember, this is a proposal. The fact that you tell me you understand what test you're having to do because of the criteria we spoke about is sufficient at level 5, okay? So, let's summarise that, okay? I know there's a lot to take on board, okay? If I'm looking for differences and I'm using at least interval data, I need to think about, is it between or within subjects? How many groups or means do I need to compare? Okay? If it's 2 groups only, we go t-test. If it's more than 2 groups, an ANOVA. Okay? If everyone does all conditions within subjects, if your groups are split or you're comparing different populations between subjects. Yeah, we get that, we understand? Good. So, little bit of an illustration here, okay? That'll definitely help when you're putting your proposal together, okay? So, parametric. If we have interval or ratio data, first question you've asked, as you've collected your data, okay? We then look and say, right, am I now looking for a relationship or am I looking to analyse mean differences? Okay, let's assume we're analysing mean differences. Now we need to think, how many groups have I got? If it's 2, okay, then we need to decide whether we have a between or within subjects design. Okay, ultimately, if it's between independent t-test, if it's within paired t-test, and the same on the bottom, 3 or more. Between or within will dictate whether it's an ANOVA or a repeated measures ANOVA. Okay? So it's a nice little illustration there which tells you which test to do at the end. Yeah? So when we put our proposal together, and if you think about that, if you just follow that, you will be able to construct in your method and tell me what analysis you're going to do and how you're going to get there. Quite simply. Yeah? I'm not asking you to then interpret results, etc. at the minute because it's a proposal. Okay? But turn to that if you get a bit stuck or you're unsure. Turn to this and it might make things a little bit clearer for you in terms of what test to do. Okay? So, what I'm going to get us to do is input some data. Okay? I'll put stuff on Moodle, some step-by-step guides. We're going to input some data. we're going to actually do a t-test, and we're going to do an ANOVA. Okay?